Okay, our goal is to evaluate sine, cosine, or tangent of a certain angle given that we know another trig value at that angle and a certain quadrant that it's in. Okay, so what does that mean? Let's start by recalling the following. From last class, we know that sine squared theta plus cosine squared theta is equal to 1. Okay, this is the Pythagorean identity. It is derived from the Pythagorean theorem on the unit circle. Okay, so we want to find tan of theta given that cosine of theta is equal to -5/13 for pi is less than theta, which is less than 3π/2. So pi is between, or theta is between pi and 3π/2. Okay, so here's our goal. We want to evaluate what this is given this statement and given that we're here. Okay, we're here on the unit circle. So let's start by recalling that tangent is equal to sine of theta over cosine of theta. Okay? So we want to find tangent of theta. Well, we already know this. Okay? We need to find this. We need to find sine of theta. The tricky part about this, though, is dealing with this quadrant over here on the right. Okay, so let's recall that if we have the unit circle here, we're going to use radians instead of degrees. And if I go around the unit circle, this is 0, this is 90 degrees, or pi/2. This is pi, this is 3π/2. And so basically what this is saying here, where I highlighted, is that we're dealing with this area right here. Okay, this little quadrant, third quadrant. Okay, that's going to be important because it's going to tell us whether or not our answer is going to be a positive value or a negative value. Okay, we know that cosine, which represents the x value, is going to be negative over here in the third quadrant. Sine, which we're going to use to find tangent, because it represents the y value, is going to be also negative. Okay, so the sine value is going to be negative. Let's keep that in the back of our minds as we're kind of going through this. So how do we find sine here? How do we find this? The key is to use the Pythagorean identity. Okay, so we know this statement is true for all values of theta. And what we're going to do is we're going to plug the value of -5/13 into this equation and then solve for sine. Okay, the notation's a little tricky, so let's just recall that sine, this is the same thing as sine of theta squared plus -5/13 squared equals 1. Okay, so we're plugging in -5/13 for cosine. So what we're going to do here is we're going to use a little bit of algebra and solve for sine. Okay, so let's start by squaring this second term, and let's remember that when we square a fraction, this 2, or the square, is going to distribute to both the numerator and the denominator. So this is really -5 times -5, which is 25/13 squared, 169, equals 1. Okay, so let's isolate the sine squared term by subtracting 25/169 on both sides. So we're just moving this fraction over. Now let's simplify the right-hand side. By finding a common denominator here. So we're going to rewrite 1 as 169 over 169. Now let's simplify this fraction. So this is 144 over 169 sine of theta squared over here. Okay? So if we want to solve for sine, we have to undo the square by taking the square root of both sides. So I'm going to take the square root of the left-hand side and the square root of the right-hand side. So we get sine of theta equals square root of 144, 12, over the square root of 13. Sorry, square root of 169, which is 13. Okay, and the tricky part about this is, let's go back to the unit circle, or this drawing we made earlier. Remember that when you take the square root, there's always a plus or minus here in the front. Okay, but the idea here is we're actually just going to use the minus term because we're dealing with sine values in the third quadrant. So this has to be a minus. Okay, so that's, I think, the tricky part about these questions. Okay, so we know sine of theta. Now we're going to use this to evaluate tangent, and that's going to be our final answer, okay, once we evaluate tangent. So tangent is sine over cosine. Oops. We just solved for sine, so let's plug that in here. Okay, we just plug that right in here. And now cosine is given to us at the beginning of the problem, which is negative 5 over 13. Okay, when we have a fraction divided by another fraction, we can take that top fraction and multiply by the reciprocal of the denominator. And then we're going to multiply across. So this becomes, 13s will cancel, so will the negatives, and we get positive 12 over 5. Okay, and that's our final answer. Okay, so the value of tangent is 12 over 5. All right, let's go through an example problem, another example. So example 1. This one's going to be a little bit easier because we're finding sine instead of tangent. Okay, so we want to find sine, given that cosine is 3 over 11 and we're in the fourth quadrant. Okay, so the first thing I want to do when we're approaching a question like this is let's just recognize kind of where we are on the unit circle, which quadrant we're in. So we're here in the fourth quadrant. So fourth quadrant. So we're over here. This is quadrant 4. We know that the cosine value over here, remember it's x, the x value is over here on the right-hand side. These are going to be positive. And the sine values are going to be negative because we're below the x-axis. Okay, so our answer is going to be negative because we're finding sine. All right, so to do this, now we're going to use the Pythagorean identity. So this lesson is called Applying the Pythagorean Identity because we're going to be using it to solve pretty much all the questions we're going to see today. So we know that cosine is 3 over 11, so let's plug that into the Pythagorean identity here. I'm just going to rewrite it a little bit. So instead of cosine squared, 3 over 11 squared equals 1. Okay, now let's solve for sine. So sine of theta squared plus 9, 2 distributes to the 3, also distributes to the 11, this is 121, equals 1. I'm going to subtract this fraction 9 over 121 on both sides. Okay, now to combine these together, let's find a common denominator, which is going to be 121 over 121 minus 9 over 121. Sine theta squared. Okay, now let's combine these together by subtracting the numerators. So we end up with 121 minus 9, so 121 minus 9 is 112 over 121. And this is sine squared. Okay, and so the last thing we're going to do is undo this square by taking the square root again. Okay, and let's recall whether or not we're going to use positive or negative sign because we're in the fourth quadrant. Sine over here is negative, and so it's going to be a negative value for our final answer. So negative root 121 root 112 over 121. Okay, and then if you want, you can simplify this by taking the square root of the numerator over the square root of the denominator. We know the square root of the denominator is 11, so we can write our final answer like this. Okay, so that's our first example. All right, let's do a practice problem. So this time we're going to, instead of finding sine, we're going to find cosine, given sine, and theta is going to be between pi over 2 and pi. Okay, so like the other two questions, let's start by identifying where we're located on the unit circle. Okay, so in radians, 0, pi over 2, pi, 3 pi over 2. Okay, so if we're between pi over 2 and pi, that's going to be over here. Okay, we know that in the second quadrant here, cosine, the x value is going to be negative, and the sine is going to be positive. They're above the x-axis. Okay? So the Pythagorean identity is going to be what the tool we're going to use to find cosine, given that sine is 5 over 13. Okay, so I think our final answer now has to be negative because the cosine value over here is negative because we're in the second quadrant. So let's plug in 5 over 13 in here for sine. Cosine squared equals 1. Okay, now let's solve for sine. So we're going to solve for cosine. So 25 over 169 plus cosine squared theta equals 1. Cosine squared theta, let's subtract 25 over 169 on both sides. Okay, now we're going to combine these together by finding a common denominator. It's 169. Subtracting the numerators on the right-hand side, we get that cosine squared is equal to 169 minus 25 is 144 over 169. Now we're going to take the square root of both sides. And so cosine of theta is equal to, so it's in the second quadrant, so negative square root of 144 over 169. Well, this can be simplified. The square root of 144 is 12. Square root of 169 is 13. So our answer here is negative 12 over 13. Okay, and so that's the value of cosine of theta, given that sine of theta is equal to 5 over 13, and its theta has to be between pi over 2 and pi. Okay, and let's wrap this up by doing problem set number 1. Okay. So 2 questions here. I'll go through both of these. Let's start with the first one. So sine of theta is equal to 4 over 5. We're in the second quadrant, same as the last question, and we want to find cosine. So, number 1. Start by recognizing that the second quadrant here is going to be right here. The sine value over here in the second quadrant is going to be positive. The cosine value is negative. So sine is positive. Cosine is negative. Okay, so to evaluate cosine, we're going to use the Pythagorean identity, so I'll just plug it straight in now. So sine squared theta, that's 4 or 5 squared, plus cosine squared theta is equal to 1. Now let's solve for cosine of theta. This is 16 over 25 plus cosine squared theta equals 1. Subtract 16 over 25 on both sides. Oops, 16 over 25. Now the common denominator we're going to use on the right-hand side to combine these together is 25. So we end up with 25 over 25 minus 16 over 25. Let's subtract the numerators, and we end up with 9 over 25 is equal to cosine squared. And now to wrap this first question up, we're going to take the square root of both sides. Because cosine is negative in the second quadrant, this becomes negative the square root of 9 over 25 equals negative, this is 3 over 5. And so that is the answer for the first question in problem set 1. Okay? And let's conclude this by going through problem number 2 here. Okay? So problem number 2, this is a tangent question like we saw at the beginning of the lesson. This one's going to be a little bit different though, because this is going to be a little bit trickier. Okay, how do we deal with that? So we want to find sine, or we want to find tangent given that sine is 1 over 2. Okay, we know tangent is going to be sine over cosine. So the first thing we want to do is let's just start by recognizing kind of where we're located on the unit circle. So sine theta is equal to 1/2. And the theta value is between negative 3 pi over 2 and negative pi. Okay, so we have negative theta values. So on the unit circle, remember we can go clockwise or counterclockwise. If we're going clockwise, the theta values are negative. So if this is 0, this is negative pi over 2. This is negative pi. This is negative 3 pi over 2. So it's kind of the reverse of going around counterclockwise. And so if we're between negative 3 pi over 2 and negative pi, the tricky thing about this question is recognizing that we're actually going to be here in the second quadrant. Okay? So in the second quadrant, just like the last question, cosine of theta is equal to negative, and sine of theta is equal to positive. Okay, so recall that because we're going counterclockwise or clockwise around the circle, the theta values are negative here. Okay, so this is negative 90 degrees, negative 180 degrees, negative 270 degrees. So we're in between these 2 points, which means that our answer, well, the cosine value before we get our answer is going to be negative. Okay. So sine, let's recall that the Pythagorean identity is sine squared theta plus cosine squared theta equals 1, and let's plug in 1/2 for sine. And we're going to solve this for cosine because we need cosine to find tangent. Okay, we ultimately want to find tangent. So 1 over 4, because the 2 gets distributed here and here, plus cosine squared theta is equal to 1. And so cosine squared theta is equal to 1 minus 1/4. Well, 1 minus 1/4, if I have 1 of something and I subtract 1/4, cosine squared theta is equal to 3/4. And now we're going to take the square root of both sides here. Plus or minus. So cosine theta is equal to, well, it's going to be negative because we're in the second quadrant. Negative square root of, I'll write like this, square root of 3 over 4, which is the same thing as negative root 3 over 2. Okay, but that's not going to be our answer. We actually need to find tangent here. So tangent is equal to sine over cosine So sine we know is 1/2. And we're going to divide by our result over here. So we're plugging this in. Similar to the question we saw at the beginning of class, when I have a fraction divided by another fraction, I can take that first fraction and multiply it by the reciprocal of the denominator. Okay? So it actually doesn't matter if the negative goes up here or down here. So let's multiply across. The 2's will cancel. And we end up with negative 1 over root 3. Okay? You can leave that as your answer, or what we can do is rationalize the denominator here. I've done this a couple times in class. By multiplying by root 3 over root 3. So this is negative root 3. Well, root 3 times root 3, square root of something times the square root of something is just whatever that thing is inside the radical. And so we end up with 3 down here, and that's going to be our final answer for this question.